Thank you for joining this lesson. We're going to discuss geometric progressions and arithmetic progressions. For online one-on-one classes, kindly reach out through this number 0704 153 366. We are told that the first term of a GP is 1, while the first term of an AP is 4. The third term of the GP is the first term of the AP. The ratio of the common difference to the common ratio of the progressions is 3:2. Then you are told that the common ratio is greater than 0. Find part A, the common ratio of the GP and the common difference of the AP. So from the provided instructions, we should be able to relate a few things here. Like the first term for the GP, you know, we have a GP and we have an AP. So for the GP, what we know is that the first term equals to 1. Then for the AP, the first term equals to 4. That is the first statement. As we proceed, we find that the third term of the GP is the first term of the AP. So for the GP, we know that nth term for a GP, nth term for GP, that is a geometric progression, is usually given by first term times the common ratio raised to n minus 1. That means the third term now is going to be A r raised to 3 minus 1. This is now the third term, because n is 3. Therefore, it means when we substitute, we are going to have A, which is 1, multiplied by r, which is unknown, times 3 minus 1. This will give us the first term for the AP, because we are told that the third term of the GP is the first term of the AP. Therefore, this third term now expressed here equals to 4. And that said, we can also conclude that if r squared now times 1 equals to 4, then the value of r is either, the square root of 4 is either plus or minus 2. But we are going to stick to 2 alone, not minus 2, because it has been indicated that the common ratio is greater than 0. So we eliminate negative 2. So the only option for the common ratio now becomes 2. Further instructions are saying that the ratio of the common difference to the common ratio of the progression is 3:2. So the ratio of the common difference to the common ratio is equal to 3:2. We can change the ratios into fractions such that the known d out of the common ratio equals to 3/2. When we cross multiply, you realize that the value of d is going to be 3, because half can cancel from both cases. Therefore, the common difference for the AP is 3, and the common ratio for the GP is 2. We were finding the common ratio of the GP and the common difference of the AP. So we are done. The next case, we are finding the fifth term of the AP. The fifth term of the AP. So we know that for an AP, any other term is usually given by A plus n minus 1 multiplied by D. So for us to get the fifth term, then we need the first term for AP plus 5 minus 1 multiplied by D. This is to give us 4 plus 4 multiplied by 3. So we're going to get 16. So the fifth term for the AP is going to be 16. We're also having another part C here, which says we find the sixth term of the GP. We know that any of the term of a GP is given by the formula already stated here, AR n minus 1. So that means the sixth term is going to be A 1 multiplied by R, which is 2, raised to 6 minus 1. So this is going to be 1 into 2 multiplied, or 2 raised to, 5. And 2 raised to 5 is exactly 32. Then finally, we are told to find the sum of the first 4 terms of the GP. Now, the sum of a given number of terms for a GP when R is greater than 1 is usually given by A into R raised to n minus 1 divided by R minus 1. This is for the case where the absolute value of R is equal to, or is greater than 1, where the absolute value of R is greater than 1, and that is our case. So we're going to say the first term, which is 1, into R, which is 2, raised to n, that is 4, because you're finding the sum of 4 terms, minus 1 out of R minus 1. So this is going to be 1 multiplied by 2 power 4, which is equivalent to 16, minus 1 divided by 1. So this is going to be exactly 15.